All right, let's dive into one of the greatest stories ever told, the story of electricity. Seriously, it's like a detective novel that took thousands of years to solve, full of incredible twists and, well, some seriously brilliant minds. We're going to figure out how we went from a little mysterious spark to literally powering everything around us.
So really, it all comes down to this one big question, right? How in the world does an ancient, almost magical observation end up powering our world today? The answer is this incredible chain of lessons, one discovery building on the next, taught and learned by some of the most curious people who ever lived. So let's go way back to the very beginning.
Okay, so our story begins in ancient Greece, with what you could call the ancient spark. This was the very first clue, a little piece of the puzzle that nobody could quite figure out for a long time.
So, picture this. The ancient Greeks noticed something really weird. If you took a piece of amber, which, fun fact, is electron in Greek, sound familiar? And you rubbed it with some fur, it suddenly had this bizarre power. It could pull little things like feathers or bits of straw towards it. I mean, it must have looked like pure magic, right? But it wasn't. It was the very first lesson, our first glimpse into this incredible, invisible force.
And here's the big reveal. It wasn't magic at all. It was what we now call static electricity. And the lesson here is super important. When you rub two things together, you're not creating some magical charge. All you're doing is moving these teeny tiny particles, electrons, from one thing to the other. That little imbalance, that's the secret. That's what creates that mysterious pull.
For centuries, this was just a cool party trick. But then, people started getting serious. Thinkers like Benjamin Franklin came along and started to really study this stuff. He's the one who gave us the words positive and negative charge. And get this, he's the guy who flew a kite in a storm to prove that lightning was just a gigantic version of that same static spark. And then came the Leyden jar, which was huge. It was the first time anyone could actually store this energy, even for a little bit.
So, okay, being able to store a spark is one thing. But what's the next big problem you have to solve? Well, how do you make that energy flow? How do you turn a quick little zap into a steady, reliable stream of power? And the answer to that question came from a guy named Alessandro Volta. And wow, his invention, the voltaic pile, was a total game changer. It sounds simple, right? He just stacked up discs of zinc and copper with some saltwater-soaked cloth in between. But what he created was the world's first true battery. For the first time ever, we had a device that could create a steady, controllable flow of electricity, all from a chemical reaction.
Now, to really get a handle on this, it helps to think of it like water. Imagine electricity is water flowing through a pipe. What Volta's battery does is act like a pump. It creates pressure, and in electricity, we call that voltage. And that pressure is what pushes the water or the current all the way through the pipe.
And just like a pipe can have skinny sections or gunk inside that makes it harder for water to flow, some materials make it harder for electricity to flow too. They create a kind of friction. We call this resistance. Now, resistance sounds like something you don't want, right? But here's the incredible thing. Learning to control this very property would be the key to creating artificial light. All right, so for the longest time, science had two different stories going on. In one corner, you had electricity, and in the other, you had magnetism. And everyone, everyone, thought they were two totally separate things, two different forces of nature, completely unrelated. But they were about to find out they were very, very wrong.
Yeah, the next huge lesson didn't come from some big, fancy, planned-out experiment. Nope, it came from a total accident, right in the middle of a college lecture. And this one little moment, it changed everything. So this professor, Hans Christian Ørsted, is giving a demonstration. He turns on an electric current flowing through a wire, and he just happens to notice that the needle on a compass sitting nearby twitches, just a little wiggle. But he realized what that meant, and it was absolutely profound. The electricity in the wire was creating a magnetic field. Suddenly, those two separate worlds weren't separate at all. They were connected. And let me tell you, once that connection was made, the floodgates opened. Ørsted's discovery was the key that unlocked the door to putting electricity into motion, to making it do things for us. This is where our story really kicks into high gear.
And this is where Michael Faraday steps onto the scene, an absolute genius. He looked at what Ørsted found and basically flipped the question on its head. He thought, okay, so electricity can make a magnet move, but can a moving magnet make electricity? That one question. Man, it was about to change everything. And what he discovered was that the answer was a huge yes. It works both ways. If you send electricity through a coil of wire near magnets, you get motion.
That's the electric motor. And if you do the opposite, if you move a magnet near a coil of wire, you create an electric current. And that's the electric generator. The motor and the generator. Think about it. These are the two inventions that literally built the modern world.
So now we have generators, right? We can make huge amounts of electricity. But that brings us to the final epic problem. How do you get all that power from the generator to every single house, every factory, everywhere? This final challenge sparked one of the biggest showdowns in the history of technology.
On one side, you had the superstar inventor Thomas Edison. He was all in on a system called direct current, or DC. It's pretty simple to understand. The electricity just flows in one steady direction. And he even built the first power grids based on it. But his system had one major, and I mean massive flaw.
And that flaw was distance. With DC, you lose a ton of energy in the wires over long distances. So an Edison power station could really only send electricity about 800 meters. That's like half a mile before it just fizzled out. To power a whole city, you would have needed a power plant on pretty much every other street corner. It just wasn't practical. But then, on the other side of this fight was another genius, Nikola Tesla. And he had this completely different, kind of weird idea called alternating current, or AC. With AC, the electricity doesn't flow in one direction. It actually zips back and forth, reversing direction super fast. It sounds strange, I know, but AC had a secret weapon up its sleeve.
And that secret weapon was the transformer. See, with AC, you can use a transformer to crank the voltage way, way up, which lets you send it hundreds of miles with almost no energy loss. Then, when it gets to your neighborhood, another transformer steps the voltage way back down to a safe level for your house. This one trick made AC so much more efficient, it wasn't even a contest. AC won the war of currents hands down, and it's why our power grid works the way it does today.
But here's the funny thing. Even though AC won the big war for the grid, the story isn't over. We actually use both currents all the time. The AC is what comes out of the wall socket, powering your big appliances. But all your electronics, your laptop, your phone, they can't use AC. They need low voltage DC. So that little power brick you plug in, its whole job is to turn AC into DC. So yeah, even though Tesla won the war, you're actually using Edison's DC to watch this right now?
So when you think about it, from that first weird observation about amber to this massive, invisible network that powers our entire civilization, it's just this incredible story of human curiosity. It's a chain of lessons, one building on top of the other. And it kind of makes you wonder, doesn't it? We figured out how to harness this incredible invisible force. What's the next one we're going to unlock?